is a smart train. Why smart? Because it can guarantee arrival times. Because it can predict part failures. Because it can take market share away from an airline. That is what makes it smart. This is what we should be talking about when we talk about the Internet of Things. But instead, we're talking about sensors and devices. But here's the thing. For as smart as these devices are, the stuff we're doing with them can still be kind of dumb. See, the Internet of Things is only half the picture. It's the materials, the infrastructure. To make it truly work, we have to enable those things to work in tandem with everything else. Historical data and patterns that bring together data on customers, suppliers, labor schedules, product history, transactions, and more. We're talking about the kind of contextual information that it takes to understand what's really happening right now. It's the insight, and more importantly, business value that comes when you bring all these streams together. We call it the analytics of things. It's how we enable retailers to have fully automated checkouts, saving billions annually in lost time and labor costs. It's how manufacturers predict and repair machines long before they fail. It's how cities can create a holistic energy grid, rewarding citizens for reducing their total energy footprint. It's how all these millions of things actually result in smarter decisions. So how do we make that happen? How do we build the analytics of things? It takes the expertise of someone who's seen the evolution of connected devices. It takes the intelligent approaches, not just to those devices, but to real-time data streams and web-scale analytics. It takes someone who can use deep analytics and parallel speed to get easy access to answers, who can pull together tons of data in a data lake or warehouse for easy, fast analysis.
History class taught us about the Industrial Revolution, when steam power changed how things were manufactured. But there hasn't been just one industrial revolution. The manufacturing industry has reinvented itself many times. The first industrial revolution is the familiar one. Beginning in the late 18th century, manufacturers used steam engines and hydraulic power in factories to make production more efficient. The second revolution began in the late 19th century, when electricity and assembly lines made mass production possible. The third took off in the 60s, when advances in computing enabled us to program machines and networks. Today, we're at the beginning of a fourth industrial revolution. Industry 4.0 is about connecting the digital and physical worlds. Today, most manufacturers' key assets are a part of the physical world. The workers, machines, tools, and inventories that drive both the production process and the end product that customers use every day. But emerging technologies allow manufacturers to use data produced by these physical assets to drive insights based on data. These technologies will enable the construction of new solutions to some of the oldest and toughest challenges manufacturers face in growing and operating their businesses. Eliminating unplanned downtime in the factory. Ensuring you never start work on the production floor that can't be finished with the material, labor, and machines you have on hand. Tripling the leverage you get from costly support labor and specialized tech talent. Changing the dynamics of your channel and creating new sources of revenue. Enabling your products to sell services for you. Growing your data business as big as your product business. Using customer and channel connectivity to achieve unprecedented levels of customer service. And the changes for the industry as a whole will be even broader, as broad as we've seen in past revolutions. Industry 4.0 will change the basis of competition, alter how manufacturers win customers, shake up the structure of the manufacturing industry, and give you the opportunity to make history.
What if there's a technological advancement so powerful that it transforms the very basic pillars of our society? A technology which fundamentally influences the way that our economy, governance systems, and businesses function, and could change our conceptual understanding of trade, ownership, and trust. This technology already exists, and it's called cryptocurrency. People often think of Bitcoin as only virtual money or a transaction system. But if you look closer, you'll see that the monetary aspect is just the tip of the iceberg. That's because Bitcoin is a groundbreaking internet technology for which money is merely one of the possible applications. Money exists to facilitate trade. Through the centuries, trade has become incredibly complex. Everyone trades with everyone worldwide. Trade is recorded in bookkeeping, and this information is often isolated and closed to the public. For this reason, we use third parties and middlemen we trust to facilitate and approve our transactions. Think of governments, banks, accountants, notaries, and the paper money in your wallet. We call these trusted third parties. This brings us to the essence of Bitcoin. Bitcoin software enables a network of computers to maintain a collective bookkeeping via the internet. This bookkeeping is neither closed nor in control of one party. Rather, it is public and available in one digital ledger which is fully distributed across the network. We call this the blockchain. In the blockchain, all transactions are logged, including information on the time, date, participants, and amount of every single transaction. Each node in the network owns a full copy of the blockchain. On the basis of complicated, state-of-the-art mathematical principles, the transactions are verified by the so-called Bitcoin miners, who maintain the ledger. The mathematical principles also ensure that these nodes automatically and continuously agree about the current state of the ledger and every transaction in it. If anyone attempts to corrupt a transaction, the nodes will not arrive at a consensus, and hence will refuse to incorporate the transaction in the blockchain. So every transaction is public, and thousands of nodes unanimously agree that a transaction has occurred on date X at time Y. It's almost like there's a notary present at every transaction. This way, everyone has access to a shared single source of truth. This is why we can always trust the blockchain. The ledger doesn't care whether a Bitcoin represents a certain amount of euros or dollars, or anything else of value, or property for that matter. Users can decide for themselves what a unit of Bitcoin represents. A Bitcoin is divisible in 100 million units, and each unit is both individually identifiable and programmable. This means that users can assign properties to each unit. Users can program a unit to represent a eurocent, or a share in a company, a kilowatt-hour of energy, or a digital certificate of ownership. Because of this, Bitcoin is much more than simply money and payments. A Bitcoin can represent many kinds of property: 1,000 barrels of oil, award credits, or a vote during elections, for example. Moreover, Bitcoin allows us to make our currency smarter and to automize our cash and money flows. Imagine a healthcare allowance in dollars or euros that can only be used to pay for healthcare at certified parties. In this case, whether someone actually follows the rules is no longer verified in the bureaucratic process afterwards. You simply program these rules into the money. Ergo, compliancy up front. The unit can even be programmed in such a way that it will automatically return to the provider if the receiver doesn't use it after a certain amount of time. This way, the provider can ensure that allowances are not hoarded. A company can control its spending in the same way, by programming budgets for salaries, machinery, materials, and maintenance so that the respective money is specified and cannot be spent on other things. Automizing such matters leads to a considerable decrease in bureaucracy, which saves accountants, controllers, and the organization in general an incredible amount of time. The programmable open character of Bitcoin allows us to completely rebuild and innovate our financial sector and our administrative processes, make them more efficient and transparent, and significantly decrease bureaucracy. But there's more. In an Internet of Things, our economy will be dealing with machines that actively participate in the economic traffic. In fact, they're already here. Think of a vending machine, or drones delivering packages. These machines are unfamiliar with the concept of trust, but Bitcoin is not. Because of Bitcoin, the drone can be 100% certain that it will deliver the package to the right recipient and know for sure that it's been paid for. And we can program the vending machine in such a way that it will automatically keep track of its supplies, order new supplies from the supplier, and pay for them automatically. Of course, you'll understand that this is only the beginning. Internet technology is disruptive and breaks the status quo. It opens markets and breaks the positions of middlemen all the time. Bitcoin and cryptocurrencies have caused a paradigm shift. It's time to explore this new technology constructively and critically, and openly discuss potential applications.
Artificial intelligence for people in a hurry. The easiest way to think about artificial intelligence is in the context of a human. After all, humans are the most intelligent creatures we know of. AI is a broad branch of computer science. The goal of AI is to create systems that can function intelligently and independently. Humans can speak and listen to communicate through language. This is the field of speech recognition. Much of speech recognition is statistically based, hence it's called statistical learning. Humans can write and read text in a language. This is the field of NLP, or natural language processing. Humans can see with their eyes and process what they see. This is the field of computer vision. Computer vision falls under the symbolic way for computers to process information. Recently, there's been another way, which I'll come to later. Humans recognize the scene around them through their eyes, which create images of that world. This field of image processing, which even though is not directly related to AI, is required for computer vision. Humans can understand their environment and move around fluidly. This is the field of robotics. Humans have the ability to see patterns, such as grouping of like objects. This is the field of pattern recognition. Machines are even better at pattern recognition because they can use more data and dimensions of data. This is the field of machine learning. Now let's talk about the human brain. The human brain is a network of neurons, and we use these to learn things. If we can replicate the structure and the function of the human brain, we might be able to get cognitive capabilities in machines. This is the field of neural networks. If these networks are more complex and deeper, and we use those to learn complex things, that is the field of deep learning. There are different types of deep learning in machines, which are essentially different techniques to replicate what the human brain does. If we get the network to scan images from left to right, top to bottom, it's a convolution neural network. A CNN is used to recognize objects in a scene. This is how computer vision fits in, and object recognition is accomplished through AI. Humans can remember the past, like what you had for dinner last night. Well, at least most of you. We can get a neural network to remember a limited past. This is a recurrent neural network. As you see, there are two ways AI works. One is symbolic-based and another is data-based. For the database side, called machine learning, we need to feed the machine lots of data before it can learn. For example, if you had lots of data for sales versus advertising spend, you can plot that data to see some kind of a pattern. If the machine can learn this pattern, then it can make predictions based on what it has learned. While 1 or 2 or even 3 dimensions is easy for humans to understand and learn, machines can learn in many more dimensions, like even 100 or thousands. That's why machines can look at lots of high-dimensional data and determine patterns. Once it learns these patterns, it can make predictions that humans can't even come close to. We can use all these machine learning techniques to do one of two things: classification or prediction. As an example, when you use some information about customers to assign new customers to a group, like young adults, then you are classifying that customer. If you use data to predict if they're likely to defect to a competitor, then you're making a prediction. There's another way to think about learning algorithms used for AI. If you train an algorithm with data that also contains the answer, then it's called supervised learning. For example, when you train a machine to recognize your friends by name, you'll need to identify them for the computer. If you train an algorithm with data where you want the machine to figure out the patterns, then it's unsupervised learning. For example, you might want to feed the data about celestial objects in the universe and expect the machine to come up with patterns in that data by itself. If you give any algorithm a goal and expect the machine, through trial and error, to achieve that goal, then it's called reinforcement learning. A robot's attempt to climb over the wall until it succeeds is an example of that. So there you go. Thanks for watching, and if you like my videos, please subscribe.